Good morning, everyone. This is one more session with respect to Linux system programming. So, in this session, today we need to discuss the concept called signal handling. That is nothing but interrupt handling. So, before starting with the today's session, if my voice is clear as well as able to see the screen properly, please type 1 in the chat box. Again, before starting with the today's session, if my voice is clear, able to see the screen properly, please type 1 in the chat box. Okay, thank you very much. I hope whatever the discussion happened in the last lecture, uh, I uploaded the PDF, right? Not Saturday, Friday only I uploaded, Thursday only I uploaded. Please cross check that in your LMS. Again, so whatever the discussion happened in the last session, scheduling policies. So I'm not uploaded in the Saturday session, but already Thursday I uploaded. Please cross check it. Okay. So in a Linux system programming, we are entering into the second chapter, we can say. In the Linux system programming, today we are entering into the second chapter, that is nothing but signal handling, also called as a interrupt handling. So from the last few sessions, we are trying to understand the concept of process management. We are trying to understand what is a process. We are trying to understand how to create a process. We are trying to understand what is the life of an executable file and what is the life of a process. We are trying to understand background process and foreground process. We are trying to understand for every process, there is a parent process. We are trying to understand what is a bash, what is the shell, different types of shells, what is the need of a shell in a command-based environment. That type of discussion happened. And what is the hardware multiprocessing, what is the software multiprocessing, that type of discussion happened. And what is the role of the process manager in this multiprocessing environment, that we are trying to understand. And some terms we are trying to understand: response time, turnaround time, and starvation time, and throughput. Such type of terms we are trying to understand. We are trying to understand one function called SYSTEM. Will you agree? If you agree with this point, type 2 in the chat box. We are trying to understand one function called SYSTEM. We are trying to understand one function called P error. We are trying to understand one function called P error. We are trying to understand one concept called error number. So if you want to display the proper error message, we need to use P error function. We are trying to understand the library functions and system calls. System calls are the functions supported by the can you tell me? Supported by operating system. Library functions are the functions supported by the compiler. And now can you tell me, system calls executes in a user space or in a kernel space? Can you tell me, system calls executes in a user space or in a kernel space? Using the system calls, we are trying to communicate with a manager. Will you agree? Using the system call, we are trying to communicate with the managers. We used one very important system call called fork system call. Fork system call is used to create a duplicate process. We are trying to understand what is the significance of a /n. Yes or no? Type it on the chat box. We are trying to understand what is the significance of a /n in a printf. If you don't use a /n in a printf, what happens? We are trying to understand. We are trying to understand orphan process, zombie process, how to remove those things we are trying to understand how to achieve the multi-processing environment. All these discussion happen in the last few sessions. So today we are, as I mentioned today, as I told you, today we are entering into the second chapter of this Linux system programming, that is called signal handling, or also called as a interrupt handling. If all of you ready with pen and paper, if all of you ready, type 3 in the chat box. If all of you ready with this things, type 3 in the chat box. Okay, well and good. So signal handling, or also we can call as a interrupt handling. First we need to understand what is the signal. So two things we need to understand here. First thing is, what is the signal? Second thing we need to understand, how to handle it. So two things, 2 points we need to understand. One, we need to understand what is the signal. Second thing, we need to understand how to handle it. Now, can anybody tell me, whenever I'm talking about a compilation stages, after compilation stages, when I discussed errors, I hope you might have remembered, there are two types of errors. One is a compile time error, and another one is a runtime error. Will you agree? There are two types of errors. One is a compile time error, and another one is a runtime error. Can anybody tell me who will generate a compile time errors? Can anybody tell me who will generate this compile time errors? Obviously, compiler will generate this compile time error. Perfect. Can anybody tell me who will generate a runtime errors? Runtime errors are generated by an operating system. Will you agree? Runtime errors are generated by an operating system. Okay. Now, can you tell me one of the runtime error? Can you tell me one of the runtime error? Can I say segmentation fault? Segmentation fault is one runtime error. One more runtime error, can I say floating point error? Floating point error. Now, will you agree, in your program, if you're trying to divide with 0, in your program, if you're trying to divide with 0, you will get this floating point error. Will you agree, when your program is trying to access unauthorized memory, can I say that is a segmentation fault error? But actually, we need to say those errors are called as signals, disturbance to a normal process execution. Note it down. What is the meaning of a signal? Signal is nothing but a disturbance to a normal process execution. Again, disturbance to a normal process execution. So whenever a program is executing normally, whenever a program is executing normally, whenever a program is executing normally, because of any reason, if this process execution get disturbed, because of any reason, if this process execution get disturbed, we need to say the process got a signal. We need to say a process got a signal. Again, signal is nothing but a disturbance to a normal process execution. Again, I'll write it here. Signal is nothing but signal is a disturbance to a normal process execution. Now my question is, who will receive the signal? Now can you tell me who will receive the signal? Can I say a process will receive the signal? Again, who will receive the signal? Meaning is a process receives the signal. Again, a disturbance to a normal program execution. So suppose you written 100 lines of code. Suppose if you written 100 lines of code, because of any reason, this execution get disturbed. Because of any reason, if this execution get disturbed, can I say the process, we need to say technically the process got a signal. Signal is nothing but a software interrupt. Again, signal is nothing but a software interrupt. Have you heard the term interrupts? In microcontroller or in microprocessor, you might have heard about the interrupts. But the term interrupt we need to use with respect to hardware. Again, the term interrupt we need to use with respect to hardware. But with respect to operating system, we need to say if any process, when it is executing, if the process got disturbed, so then we need to say a signal. Suppose I written few lines of code. I written C is equals to A by B. Will you agree this is one expression in our C language? C is equals to A by B. Will you agree this is one expression? In this expression, if the second operand is 0, in this expression, if the second operand is 0, can I say because of this line, the process execution get disturbed? Because of this line, the process is getting an interrupt. Why? Because divide with 0. So floating point exceptional error. So will you agree, because of the second operand is 0, the total process execution get disturbed? Because of the second operand is 0, total process execution get disturbed? Will you agree? Please let me know. And suppose if one more example, if I take one integer pointer, if I take it. Now will you agree this is a null pointer? If a pointer is holding the 0, will you agree it is a null pointer? If a pointer is holding the 0, will you agree it is a null pointer? Please try to respond it, those who are comfortable with the keyboard. Otherwise, I'm not getting, are you getting the points or not? Are you listening the points or not? Okay. So, if I take one pointer, if the pointer is holding the 0, can I say that is a null pointer? If you're trying to dereference this pointer, can you tell me what happens? If you are trying to dereference this null pointer, will you agree? You will get runtime error that is called a signal, that is called a segmentation fault. Segmentation fault. Now, can you tell me, when my process is in a while one loop, how will you terminate this process? When a process is in a while one loop, can you tell me how will you terminate this process? You will press Ctrl C. This is also one type of signal. Again, this is also one type of disturbance to a process execution. Normally, the process need to execute while one, but you want to terminate that process in middle. When you want to terminate that process in middle, normally you will press Ctrl C. That Ctrl C is also one type of signal. one type of interrupt. If you think about a microcontroller, there is a serial interrupt. Will you agree? There is a serial interrupt. There is a timer interrupt. There is some external interrupt. Will you agree? This type of things will be there. Here also, divide with zero is one signal. Segment unauthorized memory is a signal. Control C is one of the signal. Like this, there are so many signals are there. There are so many signals are there. So, what is the meaning of a signal? If a process is executing normally, because of some reason, if the process execution get disturbed, if a process is executing normally, because of some reason, if process execution get disturbed, we need to say the process got a signal. The process got a signal. Now tell me, whenever I use the term called signal, we need to think with respect to operating system point of view. Again, when we think about the term called, when I use the term called signal, that is with respect to operating system perspective or point of view. But when I use the term called interrupt, that is hardware point of view, means there is no operating system involvement there. If you're getting this point, type 2 in the chat box. The term signals are called as software interrupts. Again, the term signals is called as a software interrupts. Operating system level disturbances. Again, operating system level disturbances. Whenever we use the term interrupt, that is hardware level disturbances. There is no OS involvement in that. Okay, so let's see this. A signal is a notification to a process that an event has occurred. Something is occurred. Again, a signal is a notification to a process. A signal is a notification to a process that an event has occurred. Now, I hope all of you know that in your smartphones, suddenly some notifications comes. One pop-up window will come, notification or something. So can I say that is also one type of signal, a disturbance? Suppose you are listening the song through your mobile, some WhatsApp notification came. Will you agree? Little bit disturbance will be there to your normal process execution. So a signal is a notification to a process that an event has occurred. Event means something. Some additional things are happened. Some extra work has happened. It's clear? A signal is a software interrupt. A signal is nothing but a disturbance to a normal process execution. A signal is a notification to a process. A signal is nothing but a notification to a process that event has occurred. Signals are sometimes called as software interrupts, as I told you here. Signals are sometimes described as a software interrupts, means operating system level disturbances, not the hardware level disturbances, operating system level disturbances. Now my question is, who will receive the signal? What will be your answer? Who will receive the signal? What will be your answer? Answer is process will receive the signal. Answer is process will receive the signal. One of the student is asking why it happens, why it is sometimes, not every time. See, If it is every time, it is not called as a disturbance. BE9N3. If it is every time, it is not called as a disturbance. You are doing some work. If you are doing some work, or you are in a room, or you are in a PG, or in your house, suddenly what you called bell, suddenly outside somebody came and they knocked the door. Can I say that is a disturbance? You are doing your regular work, you are doing some work, suddenly somebody knocked the door. So can I say that will not happen every time? E9N3. So when you are doing your work and suddenly something happens, your work get disturbed, then we need to say that is a signal, that is an interrupt. Is it clear? No? So when you are doing, when the process is executing normally, because of some reason, if a process got disturbed, then we need to say signal. Now tell me, if the pointer is holding the valid address, will the segmentation fault comes when you dereference? Again, if a pointer is holding the valid address, whenever you dereference it, will the signal, what you called segmentation fault comes? No. If a pointer is holding the wild address, if a pointer is holding the others memory address, then only. That is not going to happen every time, right? Second, if you're trying to divide with 0, suppose my expression is c is equals to just a minute, suppose my expression is c is equals to a by b, only if the b is 0, then only you will get divide with 0, otherwise you will not get that error. Otherwise your process will execute normally. I hope you understood. So if it is every time it is happening, that is not called as a signal. When your process is executing normally, because of any event, because of something, if your process execution get disturbed, then we need to call as a, technically we need to call as a process got a signal. Technically we need to call as process got a signal. So who will receive the signal means, answer is process will receive the signal. Next point, try to understand. A signal may be received either synchronously or asynchronously, depending on the source of and the reason for the event to be signaled. Again, very important point. A signal may be received either synchronously or asynchronously, depending on the source of and the reason for the event being signaled. Again, there are two situations the process receives the signal. One is synchronously and another one is asynchronously. Can anybody tell me in a general way what is the meaning of synchronous? What is the meaning of synchronous? General way, not a technical way. What is the meaning of synchronous? So, because of this reason, because of this time, at this time, if you know that this interrupt comes, that is a synchronous. Now, will you tell me, can you tell me, you set an alarm in your mobile phone. You set an alarm in your mobile phone. So, at that particular time, you know that some disturbance will come. Will you agree? Again, suppose you set an alarm in your mobile phone. Now, will you agree that is a synchronous event? Please try to respond it. Yes or no? If you set an alarm, please that is a synchronous event. Meaning is, I know that at this time this is going to happen. Synchronous event. Now, some notification came from your Gmail. Is it a synchronous or asynchronous? Some notification came in your Gmail. We don't know when it is going to come. Asynchronous event. Asynchronous event. One of the student is asking, sir, can we say if process goes to wait state, that is because of a signal? Yes, there are so many things we need to discuss. BE9K2, that is also one of the reason. Don't worry about it. We'll see this. We'll discuss one by one. Okay, don't worry. Let's slowly understand this. We are trying to understand signals. Maybe a process receives maybe either synchronously or asynchronously, depends upon the source of and the reason. It depends upon the source and the reason for the event. So at this particular time, if you know that this disturbance is going to come, at this particular time, if you know that this disturbance is going to come, that is called as a synchronous event. We don't know when it is going to come, that is called as a asynchronous event. We don't know when it is going to come, that is called as an asynchronous event. Observe one program here. (1309_1.c). All of you observe here. Just it's taking too much of time. Okay. stdio.h void main int n1 n2 n3 printf enter n1 and n2. In a simple way, we are starting this discussion. Scanf %d ampersand of n1 ampersand of n2. Okay, ampersand of n1 ampersand of n2. Now n3 is equals to n1 by n2. Printf n3 is equals to %d slash n comma n3, and my process is in a while one. Observe this very simple program. Printf PID is equals to %d slash n get PID. All of you are observing what we are trying to do here. In line number 5, I'm trying to print. Just in line number 5, I'm trying to print PID. In line number 6 and 7, I'm scanning it. Line number 9, n3 is equals to n1 by n2, and I'm printing n3. After that, my process is in a while one loop. Okay. Now, let me compile the code. Get PID, some header file. So let's include the header file properly. Header.h. Let me compile the code. Let me run the code. Now, can you tell me what is the process ID here? What is the ID of the process? Can I say 57? Now I need to give N1 as a 10, N2 as a 0. N1 as a 10, N2 as a 0. Can I say floating point exception here? Huh? Floating point exception here. Now, can you tell me, is it a synchronous or asynchronous? Because of this statement, this is generated. Because of this time, this line is executing. Because of that, this interrupt came. Answer is, it is a synchronous. Why? Because when this line is executing, at that particular time, the event is happened. At that particular time, the event is happened. Observe here. Synchronous signals are delivered to the same process that performed the operation that causes the signal. Now try to understand another meaning of synchronous here. Synchronous signals are delivered to the same process that performs some operations caused by the signal. Again, synchronous signals are delivered to the same process that performed the operation that causes the signal. Now tell me here in my program itself, I'm trying to divide with a 0. In my program itself, because of the line number 9 expression, the signal came. So that is treated as a synchronous event. All of you are getting the point? Another meaning of synchronous signals with respect to operating system terminology. Synchronous signals are delivered to the same process that perform the operation that causes the signal. That performs the operation that causes the signal. Can I say my process itself is trying to divide with 0? So that is the reason that event is happened. So this is categorized as a synchronous event. If you're getting this point, type 1 in the chat box. With respect to operating system point of view, I'm talking. So to whom I need to call as a synchronous? Synchronous signals are delivered to the same process that performs the operation that causes the signal. Asynchronous means when the signal is generated by an event external to the running process. External to the running process. What is the meaning of external to the running process? Now observe. What is the meaning of external to the running process? Now observe. If I supply 10, if I supply 2, what is the output? 10 by 2. What is the output? 10 by 2. Will you agree? 5. Now can you tell me my process is executing what? Now can you tell me my process is executing what? While 1. My process is executing while 1. Now when I press Control C now, this is from externally it is coming because of your process itself is not generated. From the external event it is coming. From the external source it is coming. All of you are getting the point? So now you tell me, this event is a synchronous event or asynchronous event. From not because of the same process, from external event if it is coming, then that is a asynchronous. Then that is a asynchronous event. I hope all of you got these 2 points. Synchronous signals are delivered to the same process that performs some operations that causes the signal. Synchronous signals are delivered to the same process that performs the operation that causes the signal. When a signal is generated by external event, so to that process, to a running process that receives a signal as asynchronous. I hope now you got this point. Next, suppose here, if you take this example, whatever the example just now I discussed it. Suppose try to observe here. Divide with 0. The following small code tries to divide with a 0, resulting the program termination floating point exceptional sig pipe signal. This signal occurred synchronously. This type of events, because of the same process, is the reason for the signal, is the reason. So then that is called as a synchronous signal. If you take one more example, my process is in a while one loop. Now tell me, when my process is in a while one loop, when we press Ctrl C for a infinite running program, the program terminates on the reception of a to quit the process int signal. This is asynchronous. So from the reason for the signal is because of some external, so then that is asynchronous. The reason for the signal because of the same process, then we need to call as a synchronous. Now the question arises, who will receive the signal? Now the question is, who will receive the signal? What is the answer? Who will receive the signal? Can I say one process receives the signal? Then who will generate the signal? Okay, receiving the signal is done by the process. Okay, well and good. Then who will generate the signal? Now try to understand. Generating the signal, the source of signal, from where the signal is generated, maybe another process, maybe another manager, maybe hardware, maybe the same process also. Again, who will generate the signal? Who will receive the signal? Answer is a process receives the signal. Who will receive the signal? Answer is a process receives the signal. Who will generate the signal? Signals may be generated by the same process, like divide with 0. Signals may be generated from another process. Signals may be generated by the other managers. Signals may be generated by the hardware. Again, signals may be generated by the same process. Suppose if the same process is dividing with 0, if the process is generated dividing with 0, can I say signals are generated by the same process or another process or segmentation fault, memory manager, or hardware, Control C. Now tell me, to press Control C, what you will do? You will use the keyboard. Will you agree? How will you press a Control C? Through keyboard. Keyboard is a hardware. SIGINT a signal. All of you are getting the point? Who will receive the signal? Answer is a process receives the signal. Who will receive the signal? Answer is one process will receive the signal. Who will generate the signal? Source of signals, maybe the same process, maybe the other process, maybe the managers, maybe the hardware. The source of signals, how many sources? Can you tell me how many sources? Can you tell me how many sources of signals here? 4. One source, maybe because of the same process. Another source, maybe because of another process. Another source, maybe because of the memory manager. Another source, maybe because of the hardware. Now tell me, whenever you are trying to divide with, whenever you are trying to access unauthorized memory, so what is the source of signal? Can you tell me, when you are trying to access unauthorized memory, what is the source of signal? Source of signal is memory manager. Signal is segmentation fault. Again, signal is segmentation fault, but the source, who will generated the signal? Can I say memory manager? Getting the point? Because of the memory manager, the signal came to that particular process. Now tell me, when your process is in a while one loop, you'll press Control C. What is the source of signal? What is the source of signal? Can I say hardware? Suppose my process is in a while one loop. We'll use kill command, kill -9 the process ID. Now what is the source of signal? Suppose my process is Y. If this process is executing infinite times, so I'll use kill -9 process number. So what is the source of signal? Can I say another process? I hope you know that whenever you execute any command, that is also becomes one process. Whenever you execute any command, that is also becomes one process. Now tell me, whenever a process is trying to divide with 0, what is the source of signal? Whenever a process is trying to divide with 0, floating point exception, what is the source of signal? The same process itself. The same process itself. If you're getting the point, who will receive the signal? Answer is very simple. One process receives the signal. What is the source of signal? There are 4 different sources of the signals. 1 may be the same process. 2 may be the other process. 3 may be the managers. 4 may be the hardware. If these points are clear, source of signal is clear, type 4 in the chat box. If the source of signal is clear, type 4 in the chat box. Now, can you tell me, in your microcontroller, just a minute, one question came. Sir, is there any chance to receive more than one signal at a time? So there are so many points we need to discuss. P2, we'll discuss that. A process can receive more than one signal, but at a time cannot be possible. But after one, another will receive. After one, another will receive. Is it clear? After one thing, another one will receive it. Okay. So, so where we are? I'm trying to tell you something. Now here, one thing I need to tell you, if this process is generating the signal, or if this memory manager is generating the signal, via signal manager, they need to deliver the signal. Again, via signal manager only, they need to deliver the signal. So how the process manager is there? Similarly, how the process manager is there? Similarly, signal manager will be there in a kernel space. And if you're getting the point, how the process manager is there, in a similar way, signal manager is also there to manage the signal, to deliver the signal to the particular process, So signal manager will be there. Let's try to understand here. Now, I'm talking about in a microcontroller, how many interrupts are there? Can anybody tell me? In a microcontroller, how many interrupts are there? One of the students are saying 5, one of the student is saying 6. Reset is also one of the interrupt, I think. Is it? Reset is also one of the interrupt. Yeah. So 5 plus 1, reset. Now, similarly, here in our operating system, there are 64 signals are there. Again, in a microcontroller, 6 in your 8051, maybe 6 interrupts, but in our operating system, there are 64 signals are there. Every signal is having one particular number. Again, every signal is having one particular number and particular name also. If I type kill hyphen L, observe, all of you are observing. When I type kill hyphen L, note down the command KILL hyphen L. When we type kill hyphen L, we got this information. Now all of you observe here. Few of the signal we need to discuss in the next few sessions. SIG-HUP signal number 1, SIGINT signal. Will you agree? We'll press Control C. Whenever we press Control C through keyboard, this interrupt is generated. SIGINT signal. Again, whenever all these are macros. Every signal is having one number with respect to operating system. Again, signal is a software interrupt. So every signal is having one number. When we press Control C, my process will receive which signal? What will be your answer? When we press Control C, my process will receive which signal? Answer is SIGINT signal. You need to say SIGINT signal. Again, when we press Control C, my process will receive which signal? Answer is SIGINT signal. Control signal number 2. When my process is trying to divide with 0, what is the signal we will receive? When my process is trying to divide with 0, which signal will receive? Signal number 8, SIG-FPE, floating point exception. SIG-FPE, floating point exception. Whenever we use signal number 9, that is called forceful killing. Signal number 9, that is called as a forceful killing. I hope we might have observed these two also, SIG continue and SIG stop. When I am talking about process states, suspend state, how to suspend the process, we need to use SIG kill hyphen 19. Will you agree? We need to use kill hyphen 19 to suspend the process. To resume the process, kill hyphen 18. To terminate the process, can you tell me? To terminate the process, kill hyphen 9. Can you tell me what is the segmentation fault error number? SIG-SEG-V. All of you observe. What is the segmentation fault error number? Signal number 11. Now try to understand very interesting point about this thing is, suppose, now can you tell me my process is executing what? Now can you tell me in this my process is executing what? Can I say my process is executing while 1? Will you agree? Now what I'll do, cd linux underscore 89 signals kill hyphen 11 process ID is 65. Observe, when I type kill hyphen 11 65, can I say this process got terminated segmentation fault? Kill hyphen 11, when I type signal number, the process got signal number 11. What is a floating point exception error number? Can you tell me what is a signal number for floating point exception? Floating point exception. Okay. 12 by 2. What is the process ID? What is the process ID? Kill hyphen 8 95. See? Kill hyphen 8 95. Now tell me, this process received floating point exception error. The reason is for the source is what? Same process or other process? Now tell me, when my process got a floating point exception in this particular scenario, that source is the same process or source is the another process? Can I say source is the another process? Because I used kill command. When I use a kill command, can I say, when I use a kill command, can I say I'm trying to generate the signal? When I use a kill command, it is not the same process. B9J1, it is not the same process in this particular scenario. In this particular case, now you tell me 10 by 0. In this case also in this case also I got a floating point exception. Now can you tell me what is the source of the signal here? Same process. Because in the same process we are trying to divide with 0. But in this case 10 by 2, can I say my process is executing the while one loop? My process is executing the while one loop. Now from another terminal I am generating one signal, kill hyphen 8 97. Now tell me, who received the signal? Which process is received the signal? Can you tell me which process is received the signal? Which process is received the signal? What is the process ID? Which process received the signal here? 97. Process ID is 97. Who generated the signal? This signal, who generated? The same process? Who generated that? Kill command is generated. Will you agree? When you execute this command, can I say it becomes one process? When you execute this command, when you press an enter button, can I say it becomes one process? Now the signal is generated by the source of signal is the same process or the source of signal is the other process? Can I say source of signal is the another process? Now can you imagine now? Can you imagine now? 10 by 2. Now I'm through keyboard I'm pressing Control C. Through keyboard I'm pressing Control C. Now tell me source of signal is the same process or other process or the manager or the hardware? Now tell me what is the source of the signal? Is the same process or other process or the manager or the hardware? Hardware. Now tell me how to send a signal. Can I say using the command called kill command? Again, how to send a signal to a process? Can I say we need to use a kill command to send a signal to a process? Will you agree? We need to use a kill command to send a signal to a process. We need to use a kill command to send a signal to a process. Hmm? Command means, can I say executable file? Command means, can I say executable file? Executable file means somebody generated a code for this. Will you agree we implemented our own copy command in a C language? Will you agree? We implemented our own copy command in the C language. Similarly, you may get a doubt, sir, can we implement our own kill command? You may get a doubt, sir, can we implement our own kill command? Answer is yes. Answer is yes. Observe. What is the meaning of two? Now, can anybody tell me quickly what is the meaning of two here? What is the meaning of two here? Can I say system call? Now, can you tell me system calls are used for what? Can you tell me system calls are used for what? Can I say system calls are used to communicate with? System calls are used to communicate with a manager. Using the fork system call, you are communicating with a process manager to create a duplicate process. Again, using the fork system call, you are communicating with a process manager to create a duplicate process. Will you agree? Using the kill system call, you are communicating with the signal manager. I want to send this signal to this particular process. Again, using the kill system call, we can communicate with the signal manager. I want to send this interrupt to this process. So, can we implement our own kill command now? Can we implement our own kill command now? Answer is yes, very simple. Can we implement our own kill command now? Answer is yes, very simple. Let's see how to implement. What are the header files we need to include here? What are the header files we need to include here? Two header files we need to include. Sys types, I hope already there. Header.h. Sys types is already there. One more header file. What is that? Signal.h. Signal.h. Observe vi my underscore kill.c hash include header.h void main int argc character. What is the meaning of this? Can you tell me what is the meaning of this? Int argc character double star argv. Command line arguments. Huh? Can you tell me for predefined kill command, kill hyphen signal number process id for predefined kill command. So we are also trying to implement like that. If argc not equals to, if argc not equals to 3, I need to display the usage message. Printf usage dot slash my underscore kill signal number and process id. Written. So what are the inputs I need to supply at load time when I'm executing this code? What are the inputs I need to supply at load time when I'm executing this code? Can I say apart from the executable file name, two more inputs we need to supply. Apart from the executable file name, two more inputs we need to supply. What are those two? One is a signal number and another one is a process ID. Now observe. I'll use kill command, kill function, kill. First is the process ID, A to I, argv of 0, 1, 2, comma, A to I, argv of 1. And then error, kill. Above, observe here, for kill system call, first argument is the PID. PID is nothing but argv of 0, argv of 1, argv of 2. So will you agree first argument I am passing A to I? I hope all of you might have remembered why I am using A to I. I hope all of you can recollect why I am using the A to I. Yes? Why? Because whatever we pass through command line, those are treated as strings. First argument is this, second argument is this. And I'm using the P error. Yeah, I'm using the P error. If it is success, it will print success. If it is failure, it will print failure message. If it is success, it will print success. If it is failure, it will print failure message. Observe here. How to create a separate executable file. I hope all of you might have remembered how to create a separate executable file. -o option, -o, my underscore kill. Some proper closing is not done for this A to I. Now let's see. One of the student video is on. Please switch off it. Now I created successfully separate executable file. I created successfully separate executable file. Now let me run one program here. In this I'll do changes. Let me create a separate executable file for this. What is the name of the executable file I created now? Will you agree? P1 ./P1. Now tell me what is the process ID? What is the process ID of this process? 148. Okay. Now observe ./my underscore kill, signal number 11, process ID is 148. See? Yama used predefined kill command or my own created kill command here? Can you tell me, Yama used predefined kill command or our own created kill command here? Our own created kill command. And kill is success here. Okay. Now observe my underscore kill 148. Kill is failed here because no such process. Because that process is already no more. Because the process is already terminated. All of you are getting the point? So very simple to implement here. Just we are communicating with the signal manager. How we are communicating with the signal manager? Can you tell me how we are communicating with the signal manager here? How we are communicating with the signal manager? Using kill function. Now one thing you need to observe. Here, even though it is a success or failure, I am printing the error message. Try to understand. It is not a compulsion that only in a failure you need to write P error. Try to understand. Only in a failure case you need to write a P error. No. In a success also you can write P error. I'm not checking the failure condition here. I'm not checking the failure condition here. All of you are getting the point? I'm not checking the failure condition here. And again, you may get a doubt, sir, are we going to discuss all the 64 interrupts in the next sessions means, next few sessions means? No. Around 10 to 15 signals we are going to discuss. Is it clear? Are we going to discuss all these things means? No. Around 10 to 15 signals we are going to discuss it. So I hope you got what is the discussion going on. If any doubt till now, please let me know so that I'll address the doubts before going to the next discussion. Kill returns integer value. Upon failure it will return -1. One of the student is asking, can't we print signal name when it is occurred? Where you need to print B9 D5? Suppose, observe, one of the student is asking me to, on the command prompt, if you want to print the command signal name, no, you can't. Now observe, this is my program. What is the process ID? BE9K2. Can you tell me what is the process ID? 169. Now observe, I'm going to use 169. Which signal I'm sending to 169? Can you tell me? B9K2. Which signal I'm sending to 169 process? Which signal I'm trying to send? Can I say signal number 11? Signal number 11 is for what? Floating point exception. Can I send signal number 8? Can anybody tell me what is the signal number 8? Signal number 8 is a floating point exception, correct. Signal number 11, can you tell me signal number 11? Segmentation fault, right? Now observe, kill-11, my underscore kill-11, 171. You can send signal number 9 also, you can send signal number 2 also. Observe. My /my underscore kill, signal number 2, 173. Process terminated. Any doubt in this? How to implement our own kill command? Any doubt in the source of the signal? There are how many sources? I hope there are 1, 2, 3, 4 sources of signal, right? How many signals in a Linux OS? How many signals in a Linux OS? 64. Signals can be synchronous or asynchronous. Synchronous means because of the same process, if it is generated, you no need to remember all these signal numbers, B9, S15. Don't take a challenge to remember all these things. No need to remember all these things. Some signal numbers is interview point of view, is examination point of view. Signal number 9, signal number 8, signal number 19. 19 is for what? 19 is for what? To suspend the process. 18 is for what? Resume the process. Like this, some signal numbers you need to remember, not all the things. Whatever I'm discussing, if you remember, that is enough in an interview point of view. Is it clear? One of the student is asking, sir, in predefined we have to use hyphen. Yes, here we are not using the hyphen. Here we are not using the hyphen symbol here. If you want, you can implement that. If you want, you can implement that. So A to I will give negative number. That negative number you convert into positive and pass it. Again, For predefined kill command, kill hyphen, that is not a negative, minus. If you want, we can implement like that also. B9, V1, got the point? There is no difference. Okay. So today, for the time being, I'm going to wind up the today's session. Tomorrow, we need to discuss how to handle the signals. There is one function called a signal function. There is one function called what you called pause function, raise function. All these things we need to discuss in our tomorrow's session. And tomorrow, before coming to the class, try to recollect the concept of function pointers. Again, tomorrow, before coming to the class, try to recollect the concept of function pointers. Is it clear? Is it clear to everyone? Kill is a command as well as kill is a system call also. Again, BE8 into. In this command prompt, whatever the kill I am using, that is a command. That command internally uses the kill system call only. That command internally uses the kill system call only. System call is a function. Is it clear? BE8 into. So I'll show you one thing here. Just a minute. If I use man kill, if I use man kill, now tell me, it is showing the command information. It is showing the command information into, getting the point. If I use man to kill, if I use man to kill, now you tell me, it is showing. If I use man to kill, now tell me what it is showing. 2 means, can I say it is a function information it is showing? B8 into, I hope it is clear to you. Okay. In a tomorrow session, many more things we'll discuss it. If you have any doubt, tomorrow we'll continue up to 9 like this. Okay, then. Thank you very much for attending it. Now, at today's whatever the discussion happened, I'll upload this after 11:30. Again, these programs and this PDF, whatever it is there, I'll upload after 11:30. You can check LMS after 11:30.